All right, I think we're live, everybody. Let me just check. How do I get back to this is my first live stream, so bear with me for a second. Alrighty, I think this is the page I need to be on. Hey, Hyper Gibbon. Cool. Yeah, thanks so much for joining me on this Saturday or Sunday morning. It's Sunday morning, yep. Or maybe Sunday evening for the folks in Asia. Yeah, I wanted to kind of give you a rundown of what we've been up to the last since 0.1. So I thought maybe I would basically show you where we were and kind of then do basically a walkthrough of the code base of where we are now. And throughout that time, if you have any questions or something, I'll be kind of keeping an eye on the chat to see, and feel free to kind of interrupt with side questions. This isn't meant to be too very formal or structured. If you want me to go and take it in different directions, I'm happy to do that as well. Alrighty, so maybe to start off with where we were. So one of the things I really want from Bud from like basically day one, I don't think we're there quite yet, but so maybe day two, but is to basically be very extensible. I don't like these frameworks that you're kind of like locked into their way of doing things. I want an escape hatch, and so with that in mind, the way the Bud was originally designed was to allow you to have things like custom commands where you could kind of create your own migrate command, for example. Also supported custom generators where if you didn't like, for example, like the HTTP style we're doing things with controllers and views, you could just like make your own generator that would like have a GraphQL endpoint or something like that. And so that was kind of the mindset I was going into while designing the first version of Bud. And I kind of got it there, but I got it there through like basically pure force, brute forcing it. It wasn't, the first version wasn't super like, it was kind of hard to follow the code. And I think some of you may have realized that as you started contributing basically. And I started realizing, oh, there's actually other ways of doing things. And so where we were basically was you had this Bud command here, and you'd run like Bud run or Bud build, and it would generate this CLI package. And it's a CLI like you'd normally think of a CLI. The only difference was it was code generated. And so this gave you an enormous amount of flexibility in like what kind of CLI are you generating for your app, basically. And then it would build that command and then run that CLI with the arguments. So you could imagine basically having Bud generate a migrate CLI and then running that migrate CLI, for example. That was kind of like the custom command path. But then if you had there's just kind of the normal path of running the dev server, you would generate the CLI, you'd run the CLI, and that CLI itself would generate an app and build that app and run that app. And then the app would be like kind of your web server for serving requests. And so you kind of had this double binary thing. And, there's a lot of flexibility in that. And I'm not saying we might not end up accidentally like going back to that at some point. But I think there's a bunch of other solutions that could be better, basically, could be faster and a little less complex. Because what was unclear about this path was that like what generated code is being run where, like what runtimes are used for this part versus this part. Like when I say runtimes, I just mean helper packages that get imported inside the generated code. It was just like, and the whole flow was just quite confusing. And so, but it did provide a lot of flexibility. Like I know with this design, you could get to that world where you have this customizability from day one. But I also, one thing I also realized was that I'd written a lot of code, but not a lot of that code was kind of valuable to people. Like it was just kind of being carried along because I was planning on exposing the values. So like custom commands, for example, in the first version of Bud were in the first version, but you just couldn't use them. And the same with custom generators weren't quite enabled, but transforms were enabled where you could transform from like Markdown to Svelte. That was kind of in there, but unusable or unexposed. And so I kind of changed a little bit of the strategy where instead of setting up a bunch of like kind of pillars of things to build on, instead I'll just basically like build them as I need them. Like we're going to focus on the transforms, and then we're going to focus on the custom commands, and then like we'll find solutions at the time it's needed, basically. And then that kind of keeps the code base from getting really hairy too early on without providing a lot of value for people. So, okay, so yeah, and then so what I did basically this for version 0.2 was strip out this entire section here. So instead of generating a CLI Bud, the Bud run command just generates an app. Basically, it actually generates it into Bud internal app / main, and then it builds that into Bud app. So it also saves a lot of time basically on the boot because we're not building another binary. I'll take a quick pause here and see if anybody's asked any questions. It doesn't look like it. Cool. All right. Then I will kind of jump into the code base. So let me go here. And so I'm going to start actually at main, and then I'm going to go kind of like thread my way through the kind of code base from there. So, but main is kind of where everything starts. It's when you run the development command. So let me show you what I'm talking about. So when I do go run main and then I say -h, it's the Bud command basically. So the way this whole system works is we create a CLI, and that CLI is in the internal CLI package, and it's got all of the commands that you would expect. I'm going to show you the run command because I think that's the most interesting one. But there's quite a few commands in here, and let's see the run command. So the first thing we do is we look for your Go mod, the Go mod in your application directory. We check to make sure that the runtime is aligned with the CLI because your app has its own kind of, if you go into your Go mod, it's got its own, actually this is a better one. It uses the runtime here, and we just want to make sure that the runtime in your app's Go mod is the same as the one that's being built. So we don't really need to worry so much about versions and things. Sets up a logger. This is kind of interesting. So one thing you can do with, well, I guess HTTP is you can start listening. You can bind on sockets earlier. And so what I do here is kind of a trick to basically allow you to kind of listen on a server earlier. So while it's building, you're able to kind of click in. I can show you an example. Run example HN. This takes a little while to build, but then, okay, so I got this, and now it's kind of spinning while it's building the rest of it. It kind of hides a little bit of the latency. So we set that up early, and I'll kind of get back to that soon. The new thing, one of the new things about 0.2 is that we set up a Bud server, and this kind of consolidates a bunch of the things that the Bud 0.1 needed to do. There was like 3 things that it needed to do. There was serving generated code. So like if I, so for example, like let me go back, let me refresh the page. Like this code is is generated code, basically generated by ES-Build, and so it needed to be able to serve these on demand, basically. It also needs to be able to do hot reload, so like if I change, for example, if I remove the header here, it removes the header here. So we had hot reload, that was another kind of connection to the page. And then the last thing we had was v8. So the app would be extremely slow to reload. Like, here, let me show you how. So if I just do, I don't know, like print line like this, and it's reloading, and it reloaded in 2 seconds essentially. If we had V8 kind of also being built during this step for server-side rendering, it would be extremely slow, like 10 seconds, for example. So what we do instead is a little trick. We put a built version of V8 into the bud itself, like the bud binary, and we just kind of, hey, from the development, your app, basically, during development, we basically just say, hey, can you render this this JavaScript into HTML for me, and then Bud will do that and then send it back. And this kind of allows us not to bundle V8 into your application binary. Now, when you actually do Bud build, then you do actually get V8 embedded in, and there's no more connection to the Bud CLI. Okay, so where was I? Oh yeah. So okay, so that's kind of setting up the Bud listener as well, the Bud server listener. We set up a file system here, and let me see if I guess I will get to that in a bit. Yes, I'll get to that in a bit. We set up a generator file system. Now, this is kind of one of the unique things about Bud that I think sets it apart from some of the other frameworks that I'll talk about in a bit. We set up load v8 and then set up the file server. Now, the file server and the file system are slightly different. The file system is for kind of the Go code, and the file server is for like serving client front-end files on the fly. PubSub, that's pretty kind of an interesting thing that was added in this release. Basically, it allows you to kind of listen to when the server is ready, and that kind of helps with making the tests a little bit more deterministic. We set up the Bud server. We set up kind of a starter that's going to basically run your app. It's a command to run. This is how you need to be able to pass that listener, that socket we set up here, into your executed app, and so this is kind of a way of doing that. You pass it through the extra files in your command, basically, and then we run the app server and the app server and the Bud server simultaneously, listening for requests on each, and maybe I'll take a quick pause here and see if anybody's around. Nope, no, nothing in the chat. All good. Alrighty. Okay, so then we actually run the app server and we run the Bud server. I'm not going to really talk about the Bud server because I don't think it's that interesting. But the app server is kind of your app running. So what happens to build and run your app? Well, we first sync the generator file system to this directory called bud/internal/app. And this is kind of the meat of Bud, I would say. What this is actually doing is, there's a bit of indirection here. Let me go back, actually. So I'm going to go to when we set up the file system initially. Okay. This function is important. So what this is doing is it's loading something called the overlay. And the overlay is essentially like you can treat it like a file system where like you've got this gen fs and then you've got like open. Is this actually, yeah. You can treat it like a file system, like so you can read files, you can write. Actually, well, it's read only, but you can read files, you can walk over files, you can glob files, etc. The difference between this and a normal file system, though, is it actually when you try to read a file, it will generate code on demand for that file. And so, for example, if I try to read this app, bud internal app main, it will actually run this function here, generate file, and respond with that when you try to read that file. And so, and what a code it will run is basically this. It will run through this template. It loads you've got the typical generators have a loader. They've got state and they've got a template, and the loader just basically does what it needs to do to get to the state, and then the state is passed into the template and rendered. And this is just using text template. So what's pretty neat about this is, let me go back to this. So what's pretty neat about this is the compiler step of bud is basically just walking over your file directory, and then like it's just syncing from this generator file system to your actual file system in these locations in your app, basically. And so you can imagine, this gets back to kind of the extensibility goal that I have here, which is like, you can imagine writing your own like bud internal app GraphQL, for example, and you could like have this be a GraphQL generator, and like as long as you can insert this into kind of your like into this path here, basically, there's gonna have to be some way of doing that. Then it's just like the compiler is not going to know any difference. It's just walking over. It's just I'll show you actually exactly what I'm talking about. I know I'll get back to that in a sec. I'll show you the sync in a sec. But it's basically just walking over those files and reading them and writing them to your app directory. And so right now we've got a couple of these. We've got a main, we've got a web, we've got a controller, we've got a view, and we've got public. There's going to be a whole bunch more. So there's going to be transformers, there's going to be generator, there's going to be command, there's going to be a whole bunch more of these coming soon, basically. And so that's the file system portion of this thing. That's basically where all the Go files go, I would say. And then we've got a file server portion, which is basically, it's essentially the same thing. The only difference is that it's treated as a server. So it's, instead of running this as a file system you walk over, this is kind of when requested by the browser, like these files get generated and rendered. So if I do this, for example, it will generate in this for us. And this is kind of a glob. So like anything within this, like it could be like, actually this is probably a better one. Svelte internal. I think I can do this. Let me check, see if this works. But Svelte internal. Yeah, exactly. So it's able to kind of this particular generator is able to kind of read the path, the actual final path, and generate the code for it. So these ones actually don't get looped over and walked over and generated prior. They do actually when you do bud build, but when you're doing just the bud run, it's kind of, these are generated on demand. And that's primarily to speed up development a little bit, so you're not building so many generators at once, especially when you have more JavaScript. Yeah, let me check quickly again to see if there's anybody. Nope. Okay, we are good to go. Yeah, Yeah, let's see here. So we've talked about a little bit about the file system. We've talked, okay, so, oh yeah, we're down here now basically in run. Again, so we've synced all these files, generating the files as we need them. And then we basically, it's pretty simple after that. We just basically build the app. We build into from app/main to this bud app directory. Then we start the process. So we basically just spawn that binary, and then we watch for changes. And depending on the type of file that's changed, we either do an incremental reload. So if you've changed a front end file, we can just kind of tell the front end to refresh that page, and it will get the new file basically. But if you've changed a Go file, we actually need to do a sync again. So we resync the directory, we build it again, and we restart the process. So that's how Bud Run works. And you'll notice it's quite a bit simpler than what we had before. What we had before was we would build CLI, and then we would use that CLI to generate an app. Now we're just literally just generating the app, and but we've got some kind of hooks back into Bud for the app during development. So that's that one. I'll do also Bud build, and that kind of to show you the kind of differences between running and building. Bud build is actually quite a bit simpler. The main difference is what the flags that are passed in, and so when you sync, so the flags have things like, are we embedding, are we minifying, are we setting up the hot reload server? And with build, by default, you embed and you minify, and you don't set up the hot reload server. That's the opposite on run. And so let's look at where that makes a difference. So let's go back to Bud here, where we've set up the generators. Okay, and so one of the generators where this matters is the public generator. And the public generator, when we load the state, oh, this kind of is an interesting point. So we actually pass the file system through each of the generators too. And what this allows is for us to basically rely on other generators. And rely on actually code in the file system. So this is one of the other design decisions that I really wanted from very early on, which was I don't want all the generators to run all the time. Like I don't want you to have to scaffold when you do a Bud create project. Like I didn't want this whole mess of files that you see in kind of a Rails or Laravel project, because I feel like it's quite cumbersome for newcomers to kind of get started with, and maybe the Rails experts kind of understand each of the details of those files do. But for me, like if you're just jumping in, like it takes you a while. I mean, I remember learning Rails or trying to learn Rails actually when I was quite a bit younger, and it was just overwhelming basically, and I gave up. So I didn't want to have that for Bud. I also like the way kind of Next.js works, where like it kind of incrementally adds complexity by you add pages, you add middleware, you do all these other things. And I'm not a huge fan of the frameworks that just scaffold a bunch of stuff. So yeah, so getting back to the point, if files and things don't exist, we actually don't run the generators. We just return a FS error not exists, and then it will kind of pass over that file. And we do this in a whole bunch of places. So like the web generator needs to make sure that needs to make sure that at least one of these generators has run, like that, or one of these files is present, and these files are tied to actual generators. So did the controller generator actually generate this file? Did the public generator actually generate this file? Did the view generator actually generate this file? And if one of those is true, then we run this, otherwise we don't, basically. And the other cool thing about this that I think I found by mistake was that you really don't need to worry about the order in which generators run. You just try to read that file, and if it and the order kind of becomes apparent based on that. And so the first iteration of this kind of generator system, I had like a very explicit web needs to run after controller and public and view, and like with this kind of, I would say it's a lazy approach to generating files where you just request from the file system a file, and then maybe that generator requests another one. Like it just kind of works itself out in a very simple way, which I like. Okay, so where was I? Yeah, so I was talking about how embeds actually are different, or how build is different than run. And the primary difference is when you have this embed flag set, and this is set to true by default when you do bud build. What does it do? It basically runs a different set of commands or functions where it will actually this one's a bit slightly unique, I guess, because it's got some helper functions here, but it loops over all the public files, and then it puts them into a embed.file structure. This is something very simple, but like it basically helps put the data into the template in a way that that works. It's basically the same as what GoBin data does. So yeah, we run these commands when embedding, and yeah, and then it's passed through basically, and then like if we've got embeds, then we actually embed them. I'm trying to think if there's any others where we actually use the embed system. I think app also uses it, where if there's an embed, yeah. So if there's an embed, we actually pass basically a static module instead of trying to find it in the file system. So yeah, it's actually like when I was originally building bud run and bud build, I felt like there's going to be major differences between these two, but there's actually not. Once you figure out you need to pass these flags through. Excuse me. Once you figure out how to pass these flags through, then it's pretty easy. So I didn't talk about dependency injection, which is a pretty important topic. The interesting thing is it kind of just works. But let me kind of walk through dependency injection, because that's another piece of the puzzle. So a couple of the packages, app and controller, currently have dependency injection enabled. And let me see if I can find it. I think it's in loader. Yeah, okay. So what is dependency injection, first of all? Dependency injection allows you to do things like this, where I don't know, like we are not initializing this controller. The controller is initialized by the framework. How does the controller know, or how does the framework know how to initialize this for us? Well, it does through dependency injection. And so let's see, if I go into app and then main, the app generates, it's actually even higher level than this. The app's like, give me, all I care about is I want a web server. And so what does a web server need? It needs a router, it needs a view server, it needs a Hacker News client to generate this. And it kind of just asks these questions. Actually, I would say it goes more from this way. So what does a web server need? It needs a router and it needs a controller index, basically. It needs a public middleware and a view server. Okay, what does public middleware need? It needs an overlay server. Okay, how do you create an overlay server? And it just keeps kind of asking these questions, and it builds up this generated code until you have a web server, basically. So this is completely built into Bud. It works pretty well. Like it allows you to kind of do things like this. And what I really like about it is it's going to allow, like, this one's maybe a bad example, but like say I have like a interface instead. It's going to allow us to kind of swap out these packages based on whatever environment you're running in. So if you're running in development, it does one thing. If you're running in production, it does, it does a completely other thing. And the other thing it's going to allow is, so for your app, you have maybe one entry point, like run this server, basically. But when you start writing tests, you need to kind of build up all of this, the initializers for each test, and that can get quite intense if your app gets large enough, basically. And so what a lot of people do is they actually don't break their app up as far as maybe they should, because it takes a lot. Like, this is a lot of boilerplate code basically to write each time, and so people don't actually write this. Like they'll maybe have just one controller, and that controller handles everything. But what Bud, through the automatic dependency injection, like, gives you a way to kind of break up your app in the most, I guess, modular way you see fit, and like it will take care of just generating all that code for you and linking everything together. So there's two places where Bud has dependency injection. It's got one for building the web server, and so main needs a web server, like the main app needs a web server, and so it loads everything to build the web server, and it kind of pulls all the dependencies down through. The other place, which I just kind of enabled recently, is in the controllers themselves. And so what you should be able to do basically is have dependencies that are request scoped. And so the reason you want this is for things like sessions, like flash variable, setting flashes. So like if the form fails, like it flashes a error message back on the previous page. Keeping counts of visitors, things like that. You can actually have request scoped dependencies now. And so if I do something like session HTTP response writer, and I pass that through, let's see if this will all work. Oops, I need to go imports. It's a bit slow right now. Yeah, I need to do this. Okay. Print, that's the reason. Actually, it's my mistake. Alrighty, so let's try to reload our page here. Okay, session is nil. Interesting. I wonder if it's because I'm using Oh, you know what? This is actually a slight bug here. So if I did this, it's actually not a bug, but it's kind of a weird design, I'm realizing. So if I did this, oops, then I need to run it like this. My computer's really slow right now. Interesting. I'm kind of surprised this isn't working, but let me check what the controller is trying to do right now. Oh, you know what? I bet I did it in the wrong one. No, index. Oh, okay. I'm silly. Yep, gotta put it in here. That's why I like to actually use this kind of format and not the not the key version, because it's really easy to make that mistake and go. Okay, so let me step back again because this took a bit to get here. You can have both dependencies that are across all requests and dependencies that are request specific. And the way you determine that is if you are using either the response writer, or the HTTP request, or even the context. If you use this somewhere in here, these will tell, Bud will look through, or the dependency injection framework will look through for these specific dependencies and be like, okay, this is request specific. And what that will do then is, if I go to my generated code here, it's smart enough where it will load the same client across all requests, but it will load the response writer, or whatever request scope dependency you've asked for. It will load that per request. And so this one is shared across all the requests. It's kind of fed up through here, but the actual dependency that is request scoped is passed in each time. And so what's nice about this is if this is a database, you're not actually reloading the database each time, for each request. It's smart to be able to separate them. But from your perspective, like as a developer, you don't really need to care about the difference too much. You can just include these and it will split these from request response scoped dependencies and everything else, basically. So that's pretty neat, and that's going to basically be how we start adding some session packages and things like that. Like even middleware can fits under this paradigm, and it's pretty flexible too. Like you can define basically whatever kind of dependencies you want, pass them in here, and then you have access to them inside your actions. I'm going to take a small break here to see if there's any questions. How does error handling work? Okay, may I know if it would be wise to learn any data structures questions using Golang instead of Java, C++, or Python? This is from Anu Singh. I guess that would be a good way to learn. I'm not the best person to ask on that. When I learned Go, it was kind of out of necessity. I was running I've got a small app that I was running called Stand Up Jack, and I had it's a Slack bot for running stand-ups, and you get in one of the pieces of this is like a message broker. And so you've got like messages coming in from Slack, hey, like start my stand up or whatever. And that message broker was written in Node.js, and it was just such a mess. Like it was using some forked version of RabbitMQ, and like it was breaking all the time. And like if you are working with a Slack bot for a user, it's extremely frustrating when the Slack bot just doesn't respond. And so I would every time that would happen, I would basically lose a bunch of customers immediately, no second chances. And so I needed to get this message broker thing right. And so I had heard basically that Go was pretty popular for doing this. I was talking to TJ at the time, and he basically was all in on Go. And like I was just like, okay, I'm just going to try Go this weekend on migrating just this piece of the message broker from Node.js to Go, and I was able to do it. There was proper libraries for RabbitMQ, and it was pretty easy basically, and I got it up and running quickly, and it just didn't cause any problems after that. And so I was like, oh, okay, that's pretty nice. And so then I started kind of migrating more and more of the app. So that's a long answer to your short question, but I would say yes, anything is helpful, but the data structures and algorithms, they're applied to all programming languages. So like if you just want to learn the syntax, that's I think a good way to do it. But I would maybe just, I don't know, just come up with a project and work on it. That's my preferred approach. Hypergibbon asks, how does error handling work with initializing dependencies, i.e. connecting to the database failed? That's a great question. So let me instead do this. So new session, let's pretend this is a database and not a session. And let's say return nil, format session failed. Okay. I think this actually should just work as is. Let me just check to see. Yeah, sorry, my computer is extremely slow right now because of the live stream going on. Yeah, so what has happened basically is it it knows about errors basically. It's so error aware, and so whoops, wrong one. Let me go here. So now, like every time I refresh the page, it's going to say session failed. And let me actually try to find the code for you to show you what I'm talking about. Come on, VS Code. Load controller relies on a session. How do I do this again? I'm looking for where that error gets handled. I actually have no idea. But it does get handled. So like if you go into DI test, there's a bunch of tests around like around a database failing, sort of stuff like that, where basically how it works is, let me try to find a better example here, error. Here's a pretty good example. Okay, so imagine this is your file system where you've got a web directory, and that web directory depends on a router and a controller map. Okay, let's go to router and controller map. The router looks like this. The controller map looks, oh boy, this is long. Where's the controller map? Oh, here it is. Yeah, controller map. That relies on users and pages. Okay, so let's go up to pages and users right here. Okay, so the users controller relies on a database, and that database is right here basically, and that database could return an error. In this case, it's not, but basically when it sees a signature that looks like this, it will run that command, and if there's an error, it will fail early. I guess actually I could show that in a better way back up at the examples here. So I couldn't find the controllers generated errors, but the main should be quite a bit easier actually. If this ever loads. Yeah, okay. So yeah, this is, here it is. Okay. So it tries to load this, and if it fails, it fails to, basically it returns the error. And so there's a couple of these dependencies that can return errors, and it's able to generate it and handle it kind of in line. This might actually be a bug though, because you don't want to necessarily fail fast on these request scoped ones. You want to fail per request, and I believe this is actually failing fast. But for a database, actually, you do probably want to fail fast. You want to say, hey, this cannot connect, exit the app, and then you'll probably have some kind of something in the background that's like systemd or something that's like restart this thing and just keep trying it basically. So that's kind of the intent here is if you get an error, you return, you fail fast, and try again. Are the requests scoped dependency of subdependencies managed via CodeGen, or it's all CodeGen. The only thing that uses reflection here is the way we turn requests into request maps, which are basically like the data of the request, and that will be in controller RT stands for runtime, and we've got this unmarshal command here, which is able to kind of merge basically the URL keys with the body, the request body. It handles forms and JSON, and it merges everything into kind of one struct. This uses reflection. I actually want to get rid of this at some point, but it's a pretty big task, and so I haven't gotten around to it yet. But there is libraries that actually do this. This is the one I've been looking at, which seems pretty good. What it'll do is basically generate the code to unmarshal things, go key by key, and just like turn this field into this key into like a string, and then the key points to a number. That number you point that into, convert that into a struct string, whatever, or number, and it will generate the code to do that. That's what I want to get to eventually. Not there yet. One of the nice things about doing the generator thing though is you can then kind of have these. So say I've got this ID and I want to do like type ID int, but say the ID can't be negative basically. So you could do something like valid error if let's do this, like if ID is less than 0, return not a valid ID. Always return nil, and like, so this doesn't work yet, but it should in the future basically. So I don't know if you could probably do this actually with reflection. There might be a way, but I still would like to get to a place where it's mostly generated code, where like if it encounters this, it encounters a key that has a valid method on it, it will generate the code to run that valid method and then return it if it doesn't work. But again, not there yet. We'll get there soon. I think in the meantime, I do plan on building up the reflection package a little bit more. But yeah, if anybody's interested in that kind of thing, generating the code to unmarshal, that is a big problem that Bud has at the moment, and would love some help on that. Follow up to error handling stuff. I see controller session initialization load when. Yes, that's exactly right. Hyper. It's that's a bug right now. And it should actually be loaded in. It should be loaded per request. So that is something I'll fix. And Hyper also says that should be easy to do with reflection. Cool. Yeah. Maybe we'll just take the reflection as far as we need to go. And then for once Bud is kind of fully stable, like the interface is they're solid, like people depend on them, then we will start working on performance basically. And that will be the primary reason to generate will be for performance, not for feature capabilities basically. I don't know the reflect package as well as code generating, and so my kind of hammer of choice is code gen. And Bud is also kind of built up to be like pretty good at code generation, like so you don't really need to think too much about like it's a pretty good experience. The code gen is a pretty good experience. Unlike if you have to run this go generate command, you have to remember to run go generate before you run go run, stuff like that. So I'm definitely moving in the generate direction, but reflection for the time being could be a good solution. That is mostly all I've got to show you today. If there's anything else you would like to see, then please chime in. I guess one thing maybe that would be worth showing is how that kind of V8 stuff works, because that's a bit confusing. Maybe I'll do that, and then I'm just going to mention what I'm planning on doing for like the 0.2 series. And if you've got any feedback on that, you can either write in here, or we can have a discussion in the GitHub issues or the discussion board. Okay, so let me kind of walk through the V8 stuff. So why do we need V8 in the first place? Well, so Go doesn't run JavaScript, right, by default. And so what is the problem with not running JavaScript by default? You can't render, so React and Svelte, they have the capability of rendering JavaScript into HTML and serving that HTML. It's called server-side rendering. And why would you want to do server-side rendering? Why not just send all the JavaScript to the browser and have it render there? Well, if you send all the JavaScript to the browser, the search bots don't always see it, especially if you send a lot of JavaScript. And also, it's just not quite as performant. You're sending a small HTML page down that's requesting then more JavaScript, or maybe you've got a large JavaScript that comes with it. It's got a lot of work to do before the user actually sees anything. And so the industry's kind of moved towards the server-side rendering. There's a couple alternative approaches too, but this is kind of the primary one. And so how do you get server-side rendering working with Go? The best way that I found so far is to use V8. And so we've kind of embedded V8. Fortunately, I don't think I would have been able to do this without this package by Raj Chep, V8 Go. So props to Raj for getting this working. But yeah, basically all we need is an interface that does a eval. I don't even think this is that necessary anymore, but we basically need an interface to be able to send an expression in Go, like a JavaScript expression, and render out the result. That is the only interface we need. And so V8 provides that interface for us. And yeah, there's not that much to do here. Like maybe I'll just show the loader. So we load an isolate, and then kind of set up this global context. Like this would be like your, I guess like your window or your global in Node.js. We inject the fetch API into it. So this is actually something that I'm going to expand quite a bit in the coming weeks. I want to start adding more and more APIs to V8, because it's what's kind of come up recently is, let me quickly show you. Where is it? I think it's a pull request. Oh yeah, so there's no way currently to prevent flickering if you like change a theme or something like that. And the reason for that is that there's no way to actually, the way you typically would do that would be set a cookie and use that cookie to render, use that cookie to API here and like expose this document.cookie. Do I want to mimic what, for example, Cloudflare works? Headers. They use a headers. Here we go. Yeah. They expose this API, which isn't, I wouldn't say quite as nice, but it's standard, I guess. So I don't know. I'm right now I'm slightly leaning towards just doing what the browser does, because I don't really care that much about, like, I don't want people making having to make libraries that are like, this works with Bud, like a Bud JavaScript library. Like, I don't really want that. So I'd rather just copy what the browsers do. But there might be a good reason for kind of supporting this too. And I know this is supported in the browsers, like new header. But if for example, if you're making that cookie library, you still need to check, should I use this one or should I use the other one, right? I guess actually no, you could just use this one. So maybe this one's okay. I don't know. I'm still figuring out the details here. Anyway, there's a couple things we pass in. There's really not them. Like, this needs to get expanded quite a bit, where it's like we pass in fetch, we pass in URL support, and we pass in console. We only pass in console.log, not console.error. So there's like a whole bunch of new things we need to figure out how to pass in here. And I haven't done any of that work yet. I've just been relying on this cool package called v8 Go polyfills, which hasn't been updated in a while. So I think I'm going to need to bring this in-house basically and expand. So yeah, that's that. And then, so we've got this way to kind of evaluate JavaScript on the server. How does that used in Bud? Well, it's used in the, let me go to the views now. It's used in these two, or actually this one, the server side rendered package inside the view. And they're like yeah, okay. So there's a generate file which implements the generator file system interface, which, if you recall, I loaded up in Bud, the Bud directory right here. So in that file server directory, I had bud/view/SSR, and then this loads a file generator for serving SSR. And so that hits this function here and compiles it. So we use esbuild for compiling basically this, our ssr.ts file, or actually no, I think this stuff actually gets quite complicated, and so I'm actually not a whole 100% sure how it works at this exact moment. Okay, so we actually go to this file here, where is this file? I don't remember exactly where this file was. You know what? Actually, I think I know how this works. So there's a plugin that actually, yeah, there's a plugin that will see this file and it will actually, yeah, okay. Whew, yeah, this takes a bit to understand. So we have an entry point that actually, it's not pointing to a real file in the file system. It's pointing to basically this ESBuild plugin. So ESBuild plugin sees that file, and then it will generate. It will run the SSR generator, and the SSR generator is a Go text template that returns TypeScript basically. And so it will serve that. And why we didn't have that is we want to pass in all the views basically. And so we've got that file, and then that file has like import statements to all the views, and it kind of just ESBuild just kind of merges that all together into a big JavaScript file, and then we return that off. And then so we've got this V8, this server side rendered .js file that has all the views. It's all bundled together basically, and then all we do is we run V8 on that file. So let me see if I can actually find where that happens. That would happen. So we've served this file, and then the view server will actually, okay. Yep, okay. So there's this view runtime, RT stands for runtime, as I mentioned before. And we basically, whenever we see a view file, we run this render function, and this render function will turn the props into bytes, basically, and then it reads that SSR file that was that bundle thing together, and then it runs bud.render, which is something that's been exposed by this file here, and it just evals that, and then in evaling this, it takes in props and it returns HTML, and it gets that result back, and then we respond with that result somewhere from our HTTP server. Yeah, like right here. And so, yeah, it's a bit of a complex piece of code, but it generally does its job, and I haven't had to think about it for quite a while, which means the abstraction is pretty decent. That being said, for the 0.2 series, I do plan on kind of opening this up again. There's quite a few little issues around how props are passed through, how do errors get propagated back, things like that, that I'm planning trying to address in the next one. So that's how kind of the V8 stuff works. Let me check again if there's any questions, otherwise I'll be wrapping up. Okay, I'm seeing some, apparently there's some buffering, sorry about that. Cool, yeah, no questions. So let me just quickly run through what the plan is next. I had this roadmap set up, and I actually changed it yesterday, so I apologize if you had kind of been staking your plans on the roadmap. This is still a very early project. So basically what I want to do is build the Bud landing page and documentation this for the V3, and this will be like the first really complex website that or not complex, like really complex, but it'll be the first complex-ish website that I'll have built with Bud. And so while I don't know exactly what things need to be fixed, I anticipate there being quite a few things. And so I'll be kind of adding them to this tasks list. And so the final deliverable will be like, you can go to livebud.com and like you'll see a landing page and documentation. I can give you a quick peek. Since you're on the live stream, you get the world premiere of the website. It's still coming together. Where is it? Come on, Figma. Alrighty. Should have had this loaded already. Sorry about that, guys. Figma's slow. Yeah, in the meantime, I'll just kind of walk you through kind of the changes that I made in the discussions. So, yeah, I think it's going to be time to get that M1. This computer's a couple years old at this point, and now it's just lagging like crazy right now. Yeah, so what I originally had kind of planned was allowing you to have kind of separate environments, and then I wanted to kind of strip out Node because I realized it wasn't so necessary anymore. I put that as the next step, where basically we've got an environment generator, we've got import maps, we're able to kind of expose different types of configuration that Bud now doesn't allow you to support, doesn't expose by default. And then I wanted to try to start trying to remove Node.js. I think that'd be kind of cool if we could get it just to be a stock Go application, basically. So yeah, I wanted to do this, but I realized a couple things. The environment generator stuff you can totally do by yourself, like without actually needing it built in to the framework. This kind of stuff is basically like allow you to inject a different type of dependency depending on what environment you're in. This is not currently possible right now with Bud, but nobody's been asking for it either yet. I don't think we're quite at that spot, and so this still depends on this, and that's why I still want to add this and not just leave it into userland. This will also be configuration that it would be added to this. But yeah, so then we can support kind of multiple environments. The way I kind of see that going down is like you just could do like you pass bud env production and it will load the production environment, and then bud env dev, and then of course you can kind of override that with environment variables as well. But then yeah, you're able to build an app that doesn't have Node, and then like you're able to just kind of deploy to Heroku or Fly.io or anyone that has like the Go build pack, and not have to kind of customize it too much. So I pushed that to the next one because I think there's enough things that will pop up while building the website that like I think overall that will be a better use of time, at least initially. All right, cool. It's finally up. So yeah, this is kind of a sneak peek at the website, how it's coming together. This will be kind of the landing page. I've been working with a awesome illustrator to help out with some of the illustrations. Yeah, there's going to be quite a few sections here. This part's not quite done yet. Yeah, it's going to look like that. And then, so I haven't started the documentation page, but it's going to be one other page for documentation. And yeah, that'll be the kind of the initial version of the Bud website. Awesome. Let me see if there's any more questions quickly. The Bud repo, what's the distinction between internal and packaged DIRs? Oh, good question, Hyper. So there's less of a distinction than there used to be. So internal, actually, this one, the distinction here is actually pretty clear. So internal is anything that isn't used by the runtime, and so um, anything that like just the Bud's CLI needs. Now, the package directory is basically like the way I'm thinking about the package directory is packages that aren't Bud specific, like could be used in other repos and things like that, and or are used as kind of dependencies inside the generated code in your app. And so I can't put all that stuff in internal like I would like because your app doesn't have access to Bud's internal directory. So that's kind of the reason why the package directory is there. But I would say the first point that I made, which was like these packages could be extracted out and like put in their own repo and stuff. I would say that's less true than it used to be. I used to have another directory called runtime, and then I would put all the Bud specific runtime packages in there, and then the package directory was kind of unrelated to Bud, or tried to be like unrelated to Bud. But I think I've kind of that line has been blurred a bit. Hyper also asks, how is Node.js used now? You mentioned Svelte SSR runs in an embedded V8. Yeah, that's a good question. So maybe it's calling it Node.js doesn't make so much sense. What I mean is, I guess what I mean is Node.js resolution. And so like the way you have node modules, for example, like, and then the way like node modules are resolved in this certain way. With import maps, you literally just pass the URL and it's able to kind of resolve that through like from a CDN or something. Yeah, I guess when I say remove node support, what I guess I'm saying is remove node module support, where instead you just kind of import URLs. I would highly encourage you to watch the import map. I think it's this one. Oh no, it's DHH kind of goes through. I think it's actually just on rubyonrails.org. Yeah, he goes through it in this demo, and it seems pretty cool. Like you can basically, instead of needing to specify any packages in like install packages with npm, you can just like literally like import URL, and like it will just kind of figure out how to import it. So I could do like import whatever, import underscore from underscore, something like this. And import maps will like allow me to kind of say, okay, where does this actually, like how should this actually resolve to a URL? Because you can't just do that, but it'll resolve to like something like esm.sh/_ something like that, and then it will kind of import it. So you don't have a package.json, you don't have npm. I guess in my context, there's actually no node really already. You're right that there isn't really node here. It's mostly just npm and package.json. Yep. That is all the questions I see, and we went an hour and 15 minutes. Really appreciate your questions and taking the time to watch this. I would love some feedback. I don't know how this actually felt to watch. It's my first live stream, so hopefully this was useful. Yeah, and if you have any questions, you can reach me on email. You can reach me on GitHub. You can reach me on Twitter. And so thanks so much for taking the time today. Have a great afternoon, evening, rest of your day, rest of your weekend. Bye now.